afternoon, everyone, and welcome back to our next IGLUNA project show. IGLUNA is an international student platform coordinated by Space Innovation and bringing together student teams from all over the world to develop the technologies relevant for the future of space exploration. Our guest today is the project P10 from Canada, MISTLab, and they're developing the Roboter swarm to map and discover the planetary surfaces. We are streaming here live from the Farker's House, the Swiss Museum of Transport in Lucerne, Switzerland. But unfortunately, our guests today were not able to travel to Switzerland and be here with us. They are joining us online on Zoom. Team P10, would you like to say hello to our viewers?
Bonjour, everybody. Hello from, in my case, California. The rest of the team is sitting in Canada and Montreal. And we're stoked to be here with you today to present to you our field campaign. And with that, I think we would like to roll our video that gives you an impression of the kind of experiments that we have done, partially with the Canadian Space Agency at their testing facilities, and at a different testing site around the University of Montreal. Please enjoy the show.
Hello, my name is Giovanni Beltrame. I'm a professor in the Computer and Software Engineering Department at Polytechnique Montreal, and I'm the academic supervisor of P10 MISTLab for the IGLUNA experimental campaign.
The overall project combines projects of 6 PhD students, and each student focuses on their own piece of research. So we have, for instance, simultaneous localization and mapping. We have energy management. We do some research on new camera techniques and algorithms, as well as on human-robot interaction combined with some psychological assessments.
My name is Pierre, a PhD student, and I was working on autonomous exploration and mapping.
Hi, I'm Vivek. I work on the exploration stack of the rovers. In particular, my role with the team was to design a better exploration planner and a mapping stack that would create better maps of the environment.
Hello, my name is Hassan Fouad. I'm a PhD student in MISTLab. My contribution to the project was basically that I was responsible for handling the mechanical layout of the components and the sensors that we're using on board, and the energy management of these components as well, and for the energy and for the robots as a whole.
My name is Marcel Kaufmann, and I'm a PhD student at MISTLab as well. My part of the project consists of working on the human-robot interaction, and for that part we use virtual reality. So on the interface side, we combine computer engineering and parts of psychology to learn how both fields interact with each other and to create a model of a human operator.
MISTLab is a laboratory dedicated to the development of technologies for space, in particular intelligent systems, embedded systems, and robotics. I generally supervise the team, and I provided most of the support for the networking of the robots. The main issue with having many robots is that going to space is that we don't expect to have a Wi-Fi access point on the Moon or Mars. But what we need is to set up our own network. And this can be very tricky, especially since we don't have a centralized way of managing it. But we need to have decentralized systems so that the robots can establish connections, find each other, and are able to talk. And this was fairly difficult to establish, but in the end we have developed a solution that also provides access from externally from the robot network by an operator. And this operator is using a virtual private network. We can put it together with the robots.
In simultaneous localization and mapping, the goal is to track features over time in the environment to localize the robot. And by building a map, we're able to recognize places that were visited before to correct the localization estimate. And that's how we can achieve long-term autonomy with safe control and accurate positioning. We use 3D voxel-based mapping and frontier-based exploration. For object detection, we use a deep learning framework, and for 3D estimation of the bounding boxes detected by the deep learning model, we use 3D estimation through a stereo camera.
In virtual reality, we display multiple data streams from the rovers that depict what they are exploring in the field. So we have a remote setup, while the rovers can be kilometers and hundreds of kilometers away, as we are imagining them to be even on the moon or possibly on Mars. Of course, there is a time delay in communications when we go to other planets. So in our first trials, we had very minimum delays, and we are working on extending these for future missions. But what we saw is that in interacting with the data that we get back directly, it is better for the humans to understand where they are and where interesting objects or areas of interest might be. For our experiment, we use a set of sensors to also measure the cognitive workload of a human. The human is plugged into an EEG, so we are measuring brain waves, as well as we are measuring skin conductance and heart rate variability. We're collecting a bunch of biophysiological data to infer how cognitively challenged the supervisor is of such robotic system. And currently we're controlling 3 robots at the same time, but with our research we want to support more robots in the future as well. In virtual reality, the user is immersed.
So guys, I'll let you answer the questions unless you really
at first.
want me to answer something. I think you should do the answer. If that's okay with you.
The data, the point cloud, is visualized. So, and we have different ways of doing this. It could be mesh-like, or it could look like Minecraft, like as a reference here. And with that, they see sort of in real time how the rovers
can
see
you
the world
please also
too.
put some questions in the
So
Slack
the
for the other
users
to ask?
can dive into the 3D space and see the rovers while they are roaming around in real time.
My PhD and basically also my contribution to the project is designing behavioral layers that can be integrated on top of the missions being executed to ensure energy sufficiency for the robots. So basically like how the robots would handle leaving the mission and going to recharge in such a way that doesn't disturb the mission too much, and how to share charging stations if they need to. The first mechanical challenge, I'd say, is the fact that we needed to create proper mounts to be able to put together the sensors that we need. So basically the LiDAR, the cameras, all these things, this needed some adjustments to be able to accommodate them properly. The wheels and how they kind of, let's say, sometimes get their screws unscrewed during the execution of the mission. This is pretty much the mechanical kind of, let's say, challenging part. I'd say also more than the mechanical part was the electrical part. So I mean, different sensors needed different power supplies and power ratings, and this needed some adjustment from, let's say, the battery source that we have. So we needed to use different voltage regulators with different ratings and stuff like that to be able to provide correct amount of voltage and current for every sensor. Who wouldn't like to go to Switzerland and visit a new country and see nice scenery and all of this stuff? But I think that the bigger, let's say, gain out of it is basically the experience and kind of, let's say, trying something new and getting out of your comfort zone. I think I kind of learned a little bit from them.
Now we are going to show you some of our experiments that we did at the Canadian Space Agency, as well as field tests conducted in a more green area around the University of Montreal.
the Canadian Space Agency field. And they are equipped with several sensors. For instance, the LiDAR dome on top. In front of the first rover that you see here, we have also our Basler camera. Basler is a company in Germany who is sponsoring us for this IGLUNA campaign. And additionally, we are also using stereo cameras that are attached to the rover.
I would like to see the exploration autonomous for 3 of them.
Our project is supported by the Canadian Space Agency with a FAST grant, which means flights and field work for the advancement of science and technology. And this overall project is in collaboration with ETS, École de Technologie Supérieure in Montreal, with Professor David Saintonge, and Concordia University with Professor Emily Coffey.
Welcome back, everyone. That was a great show. And I see that we already have some questions in our YouTube chat. Don't be shy, you still have time to submit your question and we will discuss it with the students. So let's start with the first question. What is the biggest challenge of having swarming rovers on the moon?
One of the challenges on the moon is definitely that there's a time delay for communications. But we can tackle this and have had some communication delay in our system as well. Yeah, scalability is another interesting point there. So maybe somebody else wants to mention some points?
Okay, well, otherwise, let's go to the next question. Great show, MISTLab. Did you achieve everything that you were planning to do?
Of course, due to the pandemic, we did not achieve everything that we planned to do. Our human robot experiments could only take place in a downscaled version. And we hope to do our human experiments as a user study once everybody in Canada has had a chance to get 2 shots of the vaccine, so that we are safe with the human experiment side.
Great, so looking forward. Where can the technologies that you demonstrate be deployed besides the space applications?
So we can easily imagine that we can deploy such systems in a dangerous environment, such as after a disaster, let's say in a nuclear power plant, where to detect radiation or to do some cleanup in areas that are not accessible by humans or too dangerous for humans. So we can deploy such a human-aided swarm of robots to clean the environment.
Great. So if you have already thought about other applications, I have a question related to it. Maybe, can you foresee a business model for your project in the near future?
So in terms of business, there could be applications in agriculture, for instance. There could be applications in the space domain, in search and rescue. So we could license our software stack out to parties that are interested. And as we are using components off the shelf, the software solutions that we developed could be deployed on other hardware as well.
So you're still working on the project, and do you plan to continue working on it?
Yes, and in fact, we are planning to continue working on the project. As we just mentioned, the human robot experiments will still be part of the future research. And all of the team members have different focuses for their PhD studies. So each of the members will take part of this into their research. Further collaborations are also being explored. So at the moment, I'm personally collaborating with JPL for the Subterranean Challenge, where also a team of multi-robots is being deployed in the undergrounds to explore unknown environments and to find objects and artifacts there. There could also be science missions with NASA Braille, for instance, that are planned in November, or a Pangea X with ESA, Pangea and Pangea X with ESA that we would like to attend as well.
Okay, so I see you still have a lot of exciting plans for the future. Somebody is asking, I remember seeing pictures of a Boston Dynamics rover. Is it still part of your project?
Yes, team members here could also help me a bit with the answer, and it should not all be me. Giovanni, if you want to show it, you have to talk.
So we do have a RoboDog here that I'm currently making say hello. This guy was not in the current mission just because we didn't have the time to integrate the software stack in this particular robot. We do have a Boston Dynamics spot, and again we have the onboard computer for the spot here, but it requires quite some work to integrate it into a new platform. And we decided to go for a uniform platform. We have the 3 lidars, we have 3 rovers that are identical, and to simplify a bit the concept. But we are going to get both dogs to work together with the rovers in the near future.
Great, definitely our viewers are looking forward to see them also integrated as part of your project. Somebody is asking, how scalable is your system? Do you have the answer?
Sorry for the delay, there's a bit of a connection issue here. Yeah, the scalability of the system is very scalable. We're using, in fact, a programming language called Bus that is underlying as well. And Bus is designed to support thousands of robots. So the robots could talk to each other with a concept called virtual stigmergy. Stigmergy is known from ants. So ants would leave pheromones in an environment to talk to each other. And so do our robots leave virtual pheromones to communicate.
I see, and I think I have a kind of follow-up question on that. There's a question, can the system adapt to the robot failure?
I can answer this question. So concerning scalability and failures, they go hand in hand actually, because if you have 3 robots and you have 3 failures, your system is gone. So our entire software stack is based on complete lack of leaders or specified roles. So what you can have robots that have many robots, and since no role is specified, even if a robot fails, some other robot can take its place. We even have a system in place where if a robot fails, for example, its motors fail, but its computer is still working, can back up its entire state and transfer it to another robot. So another robot can take up the job that the robot was doing with all the knowledge of the failed robot. So yes, the robot, the system can definitely take into account failures, and it's made to scale up to thousands of robots. Obviously, we don't have thousands of robots handy, as they are kind of expensive. But imagine that if you have even 5 or 6, it becomes fairly fault tolerant.
Great, thank you very much for this. Yes, sure.
Oh, sorry. In addition to this, also, you might think that the swarm is relying on the human as a supervisor or operator in the system. But in fact, our robots are exploring autonomously and are only influenced by a supervisor. So one of these swarm principles is to not have a human as main centralized node in the swarm. And so our system can be working decentralized and autonomously, even if the human disconnects. So the science mission could go on until communication is reestablished, for instance.
Thank you very much. Yes, that was a really interesting, a very detailed answer to the question. At the moment, I have only one last question. What was your most surprising learning this year?
I would say we learned a lot about how hard it is to have robots network. And this was a sort of people take it, assume that we have Wi-Fi and 4G, 5G, and it makes it easy. But if you take the robots alone and you, for example, you put them in a cave, communication becomes very tricky. And establishing ad hoc networks now, it's not too hard. We have the technology, but setting it up and make it work properly was probably one of the most challenging things we've done in this experiment.
Thank you very much. I do not see any other questions in the chat at the moment, but we still have a bit of time if you would like to add anything about your project, especially since unfortunately you are not able to travel and join us here in Switzerland, if you would like to say anything else to our viewers online.
Well, we are very happy that the viewers online have joined us for our remote demonstrations. And we would like to, of course, continue this project. And as you already heard, we are planning to take parts of it to different other testing sites. So please follow us on our social media, on Twitter, at MISTLab, for instance, or at Polytechnique Montreal. And yeah, we're excited to share the science and research that we are doing with that. And you will also be able to read a few publications in the future with our names on them.
Okay, anybody else would like to add something else from the team?
Okay, I would like to mention that swarm robotics is definitely coming to our daily lives. You know, I always thought that this was like 20 years in the future, but with the current advancement of AI, of the sensors, of self-driving cars, we will see the swarming and interaction, the device-to-device interaction increase exponentially in the next few years, especially with the introduction of 5G, with device-to-device communication. And we'll see that decentralized systems as well as centralized systems will start to coexist. And we will have, I think, daily experiences with some sort of swarms. Probably the first will be the delivery robots, the logistics centers in places like Amazon or Ocado in the UK. They already have many robots working together, but they are all with a central computer. But as you increase the numbers, this becomes more and more difficult. So we'll see this sort of swarming and bio-inspired activity explode, I think, in the next few years. And I think it's a very exciting area of research. And in fact, if anybody of the listeners would like to join our team, feel free to send me a line, and we'll probably be hiring more people in the near future.
Thank you very much. So with that, I would like to conclude our project show today. And first of all, thank you to the team that you joined us. And this was a really interesting project show and a very detailed discussion with our viewers. So it's a pity that we are not able to welcome you here in Switzerland, but I hope to see you one day and meet you in person. And thank you, our viewers, for joining us today, watching live and asking so many interesting questions to the team. Don't forget to join other student project shows of IGLUNA, and thank you. Goodbye.